Picture a restaurant, a really good one. You walk in, sit down, and a waiter comes to you. You tell the waiter what you want. The waiter disappears into the kitchen. Inside that kitchen, a chef picks up your order. The chef opens a recipe book, follows the recipe, prepares your dish, and sends it back out to you. You enjoyed the meal. You never saw the kitchen. You never read the recipe. You never touched the stove. And yet, the meal happened. Every AI application in the world works exactly like that restaurant. There's a waiter, a chef, a kitchen, and a recipe. Today, we are walking through the kitchen door, all the way in, and nothing in there is as complicated as they made you believe. This is Narrator, Analyst, Practitioner, Scholar Channel. I'm the narrator, and today we are doing something special in this show. We are stepping into the world of technology. AI, programming languages, databases, the companies building the future, and the ordinary people with ordinary ideas who are already part of it. With me today are three voices who are going to make this the most honest conversation about technology you have always heard. Let me bring them in.
I'm the analyst. I look at systems, how things are designed, why they work the way they do, and what the logic underneath actually is. I want to say something up front. The technology world has a very bad habit of making simple ideas sound complicated. Today, I am doing the opposite. Every complicated word you hear in this episode, I am going to show you the simple idea hiding inside it, because the simple idea is always there. Always.
And I'm the practitioner. I build things. Real applications like coders, programmers. Real systems that real people use. And I want to be honest with you today about something most people in my world would rather I kept quiet. The distance between having an idea, just a feeling that something should exist, and actually bringing that thing to life using AI today is smaller than it has ever been in the entire history of technology. Today, I will show you exactly what that means.
And I'm the scholar. I study the history of powerful tools and the history of who was told those tools were not for them. The printing press, the telephone, the internet. Every single time, ordinary people were made to feel like outsiders looking in. And every single time, history proved that wrong. AI is the latest chapter of that same story. And today, we write a different ending.
4 perspectives, 1 conversation, and 1 promise. By the end of this episode, you will understand what AI actually is, how it runs, what languages power it, where data lives, who the players are, and most importantly, why all of this was always meant for you. Let's go. Part 1. The recipe, the chef, the kitchen, and the waiter. Analyst. We opened with a restaurant. A waiter, a chef, a kitchen, a recipe. Walk us through what each of those actually means in the world of AI.
All right. Let us start with the recipe. In the world of AI, the recipe is called a model. A model is a set of learned patterns, billions of them, built by feeding a system enormous amounts of human knowledge, text, books, conversations, code, articles. The model does not store all of that word for word. It learns the shape of it, the relationships, the patterns. Just like a recipe does not contain the actual food, it contains the instructions for producing the food. A model contains the instructions for producing intelligent responses. But here is the key thing. A recipe sitting on a shelf does nothing by itself. Someone has to cook it.
And that is where the chef comes in. In AI, the chef is called an engine. The engine is the software that actually runs the model. It reads the model's patterns, billions of mathematical values and executes them when you ask a question. It handles the heavy computation, the memory, the speed. Without the engine, the model is just a file sitting on a hard drive, doing nothing. The engine is what makes the model come alive. The chef is what makes the recipe into a meal.
And then there is the waiter. In software systems, the waiter is usually called an API, short for Application Programming Interface. The API is the messenger between you and the complex systems working underneath. Sometimes developers build something called a wrapper around that API. A wrapper is simply a cleaner interface, a way to use the system without dealing with the raw technical details. When you type a question into ChatGPT, you're using an interface that communicates with the model through an API underneath. ChatGPT itself is the full product, the entire hotel, the screen you see, the API carrying your message, and the model producing the answer, all working together seamlessly. You do not touch any of those layers directly. You tell the waiter what you want. The waiter carries it to the kitchen. The kitchen does the work, and the waiter brings the answer back to your table. These layers exist so that you and developers can use powerful AI without dealing with the enormous complexity underneath it.
So when someone says API, think of the waiter, the one carrying your request to the kitchen and bringing the answer back to your table.
Exactly. API stands for Application Programming Interface. But what it actually means, in plain English, is a structured doorway, a defined way for one piece of software to talk to another. A waiter carrying orders between the table and the kitchen. That is all it has ever been.
A narrator. There is a fourth concept worth naming here. It is called inference. Inference is the moment the kitchen actually cooks your meal. When you send a question, when the engine runs the model on your specific input and produces an answer, that is inference. Think of it this way. Training is when the chef spent years learning to cook, reading thousands of recipes, making thousands of meals, developing judgment. That happened once. It was long. It was expensive. Inference is what happens every time you order a meal. Fast, repeatable, done in seconds. The learning happened once. The serving happens millions of times a day.
So the four pieces are model, engine, wrapper, inference, recipe, chef, waiter, and the act of cooking. And every AI application in the world, every single one, uses these four things. Part 2. The world of AI models who is cooking what? Scholar. Here is a question I think every listener is sitting with. When people talk about AI, they talk about ChatGPT, Gemini, Claude, Grok, all these different names. What are these, and how do they relate to each other?
They are all models. Different recipes made by different chefs in different kitchens trying to cook the same kind of meal. Intelligent conversation, understanding language, generating useful responses. But each company has made different choices about how to build their recipe, what ingredients to use, how much time to spend training, what values to build in, and the result is a landscape of different models, each with its own strengths, its own personality, its own focus.
And then there is the waiter. In AI systems, that waiter is called an API. The API is the messenger between you and the powerful systems working behind the scenes. Sometimes developers build something called a wrapper around that API. A wrapper is simply a cleaner, friendlier interface, a way to make the system easier to use without exposing all the complexity underneath. Think of ChatGPT as an entire hotel. When you walk in, you see the reception, the dining room, the service. You do not see the kitchen. You do not see the recipe. You do not see the chef. All of that work is happening behind the scenes. The screen you interact with is the front door. The API is the waiter carrying your request inside. And the AI model is the chef preparing the response. You tell the waiter what you want. The waiter carries it to the kitchen. The kitchen does the work, and the waiter brings the answer back to your table. The entire system exists so that you and developers can use incredibly powerful AI without ever needing to see the enormous complexity underneath it.
Then there is Google with the Gemini family. Gemini Flash for speed. Gemini Pro for depth. Google has the advantage of having trained on an enormous amount of the world's information, and their models reflect that breadth. Anthropic, the company behind Claude, has built models that are particularly focused on being careful, honest, and safe. Claude Haiku for speed. Claude Sonnet for balance. Each tuned for a different kind of task.
DeepSeek, a Chinese AI company founded by Liang Wenfeng and backed by the quantitative hedge fund High Flyer, released models that genuinely surprised the industry with their capability relative to their cost. For years, the dominant belief in artificial intelligence was simple. The best models required the largest budgets, the most powerful hardware, and the biggest technology companies in the world. DeepSeek challenged that assumption. Their models showed that clever engineering and efficient training could produce systems that competed with far more expensive ones, not by spending more, but by using resources differently. In an industry where scale had long been the dominant strategy, that was a moment people paid attention. DeepSeek Chat for general use. DeepSeek Reasoner for tasks that require step-by-step logical thinking. xAI, founded by Elon Musk, produces the Grok family. Grok 3 Mini, Grok 4, models designed to be direct and fast. Mistral AI, a French company, produces efficient, high-quality models, including Mistral Small and Mistral Medium, known broadly for their efficiency and strong performance across a wide range of tasks without requiring enormous computing resources. Meta Platforms, the company behind Facebook, has released the Llama family with publicly available weights. Llama 4 Scout, Llama 4 Maverick. These are models that developers around the world can download and run on their own systems.
And then there is Perplexity AI, with sonar models built specifically for searching and finding information. Moonshot AI from China, with Kimi models, known for handling very long documents. And Alibaba Group, with the Quen family, including Quen Plus and Quen Max, models designed to be versatile and accessible across different tasks and budgets.
A narrator. What is remarkable when you look at this landscape is not the competition. It is the diversity. For most of human history, when a new, powerful tool arrived, one or two large powers tended to dominate it. AI has emerged somewhat differently. American companies, Chinese companies, French companies, open models anyone can use freely, closed models available through APIs. A genuinely global, genuinely competitive ecosystem, much of it publicly documented, accessible to anyone with an internet connection. That level of openness and global participation is unusual for a technology this powerful. So when someone builds an application and connects it to AI, they are choosing which kitchen their orders will be sent to.
Exactly. And the smartest builders do not choose just one.
Part 3. The Gateway, Why smart systems use multiple kitchens. Analyst, explain that. Why would anyone use multiple AI providers at once?
Think back to our restaurant. Now imagine that restaurant depends on a single supplier for every single ingredient. One day, that supplier has a problem. A truck breaks down. The warehouse floods. Something goes wrong. Your entire restaurant stops. Every customer waiting at a table gets nothing. A smart restaurant owner has multiple suppliers. If one fails, another steps in immediately. The kitchen keeps running. The customers never know anything went wrong. In AI, this is called a gateway. An AI gateway is a system that sits between your application and multiple AI providers and manages them intelligently. If OpenAI is slow, route to Gemini. If DeepSeek is overloaded, switch to Claude. All automatic, all invisible to the user, always on.
And here is what most people never hear. The largest companies in the world, banks, hospitals, retailers, use exactly this architecture. Microsoft Azure, the cloud platform from Microsoft, offers a service called Azure OpenAI Service. Large enterprises run AI on Microsoft's infrastructure with enterprise security, reliability, and compliance built in. Amazon has Amazon Bedrock, publicly announced and fully documented, which gives companies access to multiple AI models through a single API. Claude from Anthropic. Llama from Meta Platforms. Models from Mistral AI. All available through one API. One waiter, serving from multiple kitchens. Google has its own equivalent through Vertex AI on Google Cloud. These are billion-dollar infrastructure decisions made by the largest organizations on Earth.
And here is the part that genuinely amazed me when I first understood it fully. That same concept, multiple AI providers, intelligent switching, automatic failover, that costs enormous amounts when a large bank builds it on Microsoft Azure or Amazon Web Services, is now available to any developer anywhere in the world through publicly documented platforms. Portkey, OpenRouter, Cloudflare AI Gateway, all publicly available, all documented, all accessible. The infrastructure pattern that enterprise giants use and the pattern a solo developer can use now follows the same architectural idea. The scale differs. The concept does not.
And narrator, I want to place that in historical context. For most of human history, the tools of power were concentrated. The printing press was expensive. Early telephone networks were owned by a handful of companies. Early computing filled entire rooms and cost millions. What is happening right now with AI is the most rapid democratization of a powerful technology in recorded history. The infrastructure available to a billion-dollar company and the infrastructure available to one person with an idea are now the same thing. Different kitchen size, same recipe, same chef, same waiter. That has never been true before. Not like this.
Part 4. The language of the machine. What is programming? Practitioner. I want to go one level deeper now. Because behind every AI application, behind every waiter and chef and kitchen, someone wrote instructions. Those instructions are called code, and code is written in programming languages. What is a programming language, really? In plain English.
A programming language is simply a way of giving precise instructions to a computer. That is all it is. You know how when you write a recipe, you have to be very specific? You cannot write, add some flour. You write, add 2 cups of flour, sifted. Computers are the same. They are extraordinarily powerful, but they need extremely precise instructions. A programming language is the vocabulary and grammar for writing those instructions. Different languages exist for different kinds of instructions. Just like different human languages evolved for different cultures, different programming languages evolved for different kinds of tasks.
Let me walk through the three most important ones for understanding AI applications today. First, Python. Python is the language most closely associated with AI. It reads almost like plain English, which is why it became the default language for data science, machine learning, and AI research. When AI models are trained, when data is processed, when experiments are run, when the intelligence itself is being built, it is almost certainly written in Python. And because of this deep connection to AI research, Python is also widely used in the backend of AI-powered applications. Though it is worth knowing, any language can call an AI model through an API. The model itself does not care. It simply receives a request and sends back a response. Python is the language of the kitchen, especially when the kitchen is building the recipe itself.
Second, JavaScript. JavaScript is the language that makes the web interactive. Every button you click on a website, every animation you see, every form you fill in. JavaScript is what makes web pages come alive. Without JavaScript, the web would feel like a printed newspaper. You could read it, but you could not interact with it. In our restaurant analogy, JavaScript powers the activity in the dining room. It is what responds when the customer touches, clicks, or asks for something.
And third, Node.js. Now, Node.js is not exactly a new language. It is JavaScript, but running on a server instead of inside a browser. This matters because it allows developers to use one language, JavaScript, to build both what the user sees and what happens on the server side. The dining room and the kitchen, written in the same language. This was a significant moment in the history of web development. It made building complete applications far more accessible to developers. Node.js is one of the most common ways to build the kitchen, the server that prepares the response when a user makes a request.
And what I find historically significant about this is the trajectory. Early programming languages, COBOL, Fortran, were so cryptic that only specialists could read them at all. They looked nothing like human thought. Python looks like this. If the weather is sunny, print good day for a walk. That is almost a sentence. The direction of programming language development over 70 years has been one continuous journey toward human language, toward readability, toward accessibility. And AI is now taking that journey to its logical conclusion, where you can describe what you want in plain English, and a system translates it into working code. The wall between human thought and machine instruction is dissolving in real time, right now.
So Python is the kitchen language. JavaScript is the dining room language. And Node.js lets JavaScript work in the kitchen too.
And when you look at a real application, a legal analysis platform, a location intelligence tool, an academic publishing assistant, you will find these layers working together. The user interacts with JavaScript in the browser. The server runs on Node.js. And the AI is reached through an application programming interface, which any programming language can call. Multiple languages. One application. One seamless experience for the person using it.
Part 5. Where does the data live? Databases explained. Analyst. Every application we have described stores information. User data. Legal analyses. Location histories. Research manuscripts. Where does all of that actually live?
It lives in a database. And a database is, in the simplest possible terms, an organized filing cabinet. Imagine a very large office, thousands of files. each file labeled, each drawer organized by category, and a very fast, very precise librarian who can find any file in milliseconds. That is a database. It stores information and retrieves it exactly when asked. And most databases speak a language called SQL.
SQL. What is that?
SQL stands for Structured Query Language. But ignore the technical name. SQL is simply the language you use to ask questions to a database and give it instructions. Think of it like speaking to that librarian. Give me all the legal analyses submitted this week. Show me every user who logged in yesterday. Add this new manuscript to the system. SQL is that conversation, written in a precise, structured way, so the database understands exactly what you need. Most SQL reads almost like English. Select all users, where city equals Mumbai. That is SQL, and it is not complicated.
Now, databases come in different varieties. And the names you hear matter because different organizations use different ones for different reasons. Microsoft, whose cloud platform Microsoft Azure we discussed earlier, has a database product called Microsoft SQL Server. It has been a database of choice for large enterprises, banks, and government institutions for decades. Reliable, powerful, deeply integrated with the Microsoft ecosystem. Oracle Corporation, another enormous technology company, has Oracle Database. Oracle has been in the database business since the 1970s. Some of the largest financial institutions, airlines, and telecommunications companies in the world run on Oracle databases. When organizations need extremely reliable, mission-critical infrastructure, Oracle is often one of the platforms they choose.
But then, there are open-source databases. And this is where it gets interesting for anyone building something today. PostgreSQL, often called Postgres, is a free, open-source database that is extraordinarily powerful. It is the database of choice for a huge number of modern applications, startups, scale-ups, and even large enterprises. Free to use, publicly documented, supported by a global community of developers. MySQL, another free, open-source database, powers a significant portion of the world's websites. WordPress, which runs a large percentage of all websites globally, uses MySQL by default. And then there's SQLite, the smallest, simplest database of all. It lives inside your application itself. No separate server needed. Used in mobile apps, small tools, and offline applications all over the world.
A narrator, the existence of these free open source databases is not a small thing historically. For a long time, running a serious database meant paying Oracle or Microsoft hundreds of thousands of dollars in licensing fees. The open source movement, where developers around the world voluntarily built and shared powerful tools for free, fundamentally changed who could build serious applications. PostgreSQL is used today in applications serving millions of users, and it costs nothing to use. The democratization of infrastructure is not just about AI. It has been happening in databases, in programming languages, in development tools for 30 years. AI is the latest wave of that same tide.
So when an application stores your data, it is being placed into an organized filing cabinet. The librarian speaks SQL, and the filing cabinet might be from Microsoft, Oracle, or it might be completely free and open to the world.
For most people building something new today, it is PostgreSQL, free, powerful, trusted, and the same database that powers applications used by millions of people around the world.
Part 6. Frontend and backend. The dining room and the kitchen. Practitioner. 2 words, I want to make sure every listener understands completely before we go further. Front-end, back-end. Break them down.
Simple. The front end is everything you see. The screen, the buttons, the layout, the colors, the text. When you open an application on your phone, when you see a search box, a list of results, a profile page, you are looking at the front end. It is the dining room, the part of the restaurant the customer experiences. The back end is everything you do not see. When you press a button, something happens. Your request travels across the internet to a server. The server processes it. It queries a database. It calls an AI model. It does calculations. It sends back a response. All of that, invisible to you, is the back end. It is the kitchen. You never see it. But every meal depends on it.
And the two halves talk to each other through, there is that word again, an API. The waiter. The front end asks the back end for something. The back end goes away, does the work, and returns an answer. The front end displays that answer to you. That cycle, front end request, back end processing, front end display, is happening hundreds of times every minute in every application you use. Every time you search something, every time a page loads, every time an AI generates a response for you, that cycle is running.
And what I find beautiful about this, from a historical perspective, is how this division mirrors something much older than computing. Every complex human system tends to divide into what is visible and what is invisible. A court has its public chamber and its private deliberations. A hospital has its reception and its operating theatre. A newspaper has its front page and its editorial room. Front end and back end are not really a new invention of technology. They reflect a much older organisational pattern in human systems, now applied to software. Show the audience what they need to see. Do the complex work out of sight. Connect the two with a reliable system. That has always been how complex systems work.
So every application you have ever used, every website, every app, every AI tool, has a dining room you experience and a kitchen working behind it. And now you know both rooms exist, you know what happens in each of them, and you know that the kitchen, in most applications today, now contains an AI model being run by an engine, served through an API, storing its results in a database, all written in Python, JavaScript, and Node.js. The full picture, visible for the first time. Part 7. Real ideas, real applications, real people. I want to bring all of this, everything we have discussed, into real life now. Not hypothetically, not theoretically. Practitioner, walk me through what it looks like when a real person with a real idea actually builds something.
All right. Let me give you some ideas, real ideas, the kind that come from paying attention to the world around you. Someone looks at the legal system and thinks, ordinary people in India have no idea what law applies to them, what court handles their case, what remedies they have. What if AI could analyze a legal situation in plain language and tell them exactly what they are facing? That is a legal analysis platform. The front end, a simple form where you describe your situation. The back end, receiving that description and sending it to an AI model. The AI, trained on legal knowledge, identifying relevant laws, judgments, and remedies. The database, storing the analysis so you can come back to it. The result, a clear, structured report in language any person can understand. That is real. That application exists.
Another idea. A researcher, a PhD student, spends months trying to find the right journal for their paper. Every journal has a different scope, a different ranking, a different acceptance rate. The researcher pastes their title and abstract, and an AI reads it, scores it against a database of journals, and returns ranked recommendations, with a rationale explaining why each journal fits. Frontend, a clean submission form. Backend, the matching engine. AI, the semantic analyzer. Database, storing the journal knowledge and the user's submissions. And when the application needs to use an external AI model, it connects through an application programming interface. Developers obtain something called an API key, a secure credential that allows their software to access the AI service. The key is added to the back end of the system they are building, allowing their application to send requests and receive responses from the model. That is a real application, built on exactly the stack we have been describing.
Another one. Someone thinks, before I travel anywhere or before I send my family somewhere, I want to know right now if it is safe. Not 10 different apps. Not checking weather, then news, then traffic separately. One input, a location. One output, a risk score, a safety recommendation, and a full intelligence report across 9 categories. Weather, news, traffic, social media signals, government advisories. The front end asks for a location. The back end fetches data from multiple public sources through APIs. The AI synthesizes it all into a single coherent picture. The database stores the history. That is real. That idea is real.
A narrator. What connects all 3 of these ideas is not technology. What connects them is observation. Someone paid attention to a problem that real people face. Someone asked, why does this have to be this hard? Why does no good solution exist? That moment of observation, that question, is worth more than any programming language, more than any model or engine or database. Because without the insight, the technology has nothing to build toward. The insight is the foundation. Everything else is construction.
So the most important skill, the one no university course can fully teach, is the ability to look at the world and see the gap between how things are and how they should be.
That is correct. And here is something I want every listener to understand about the technology side of this story. You do not need to know how to write Python to recognize a legal problem that needs solving, unless you want to build the system yourself or work with someone who can. You do not need to understand SQL to realize that researchers spend months trying to find the right journal for their work. You do not need to know what Node.js is to feel that traveling has become stressful, because you never quite know what situation you are walking into. The insight does not come from the programming language. The insight comes from the person who lived the problem, from the lawyer who sees inefficiency in the courtroom, from the researcher struggling to publish their work, from the traveler trying to navigate an unfamiliar place. Technology is simply the tool that turns that insight into a working system. And today, the remarkable thing about this moment in history is that the distance between insight and execution has become smaller than it has ever been before. The person who understands the problem is now closer than ever to building the solution.
Part 8. How to be creative with all of this. Scholar, I want to ask you something that I think is on every listener's mind right now. Someone hears everything we have discussed today. The models, the engines, the wrappers, the databases, the languages, the gateways, and they feel inspired, but also, perhaps, a little overwhelmed. Where does creativity actually begin for a normal person who wants to be part of this?
It begins, as it always has, with a question. Not a technical question, a human question. What bothers me every day? What takes too long? What costs too much? What information do I wish I had, right now, that I cannot easily get? What does someone in my profession, my community, my family struggle with, that nobody has built a good solution for? That question is the seed.
And practically speaking, here is what the creative process looks like today for a non-technical person who has that seed. You describe your idea in plain language. What it does, who it is for, what problem it solves, what the user sees when they open it, what happens when they press the main button. That description, clear, specific, human, is the most valuable document in any project. From that description, AI tools today can help you understand what technology is needed, what database makes sense, what AI model fits the task, what the front end should feel like. The bridge between idea and implementation has never been shorter.
And I want to be clear about what learning looks like for someone who wants to go further. You do not need to master Python before you can be useful. You do not need to understand every detail of how a model is trained. What helps enormously is understanding the concepts: model, engine, wrapper, front-end, backend, database, API, gateway, inference. Understanding these concepts, the shape of the system, means you can have a real conversation with any developer in the world. You can evaluate a product intelligently. You can ask the right questions. You can recognize when someone is overcomplicating something simple. Conceptual literacy is not the same as technical skill, but it is enormously powerful, and you now have it.
So creativity in this world is not about writing code.
Creativity, art in every world, has always been about seeing what others have stopped seeing. The person who looks at something everyone else has accepted as normal and asks, does it have to be this way? That question has driven every meaningful invention in human history. Not technical expertise, not access to resources. The refusal to accept that a problem is permanent. AI has simply made the distance between that question and a working answer shorter than it has ever been. The question itself, that is still entirely yours.
We walked a long way today, from a restaurant to the models and engines and wrappers inside every AI system, from Python and JavaScript and Node.js, to the databases that hold the world's information, from Microsoft and Oracle to PostgreSQL that anyone can use for free, from OpenAI and Google and Anthropic and DeepSeek and Meta and Mistral and all the others, to the gateways that manage them intelligently. And from all of that, back to the only thing that truly matters. The idea, the human insight, the question someone was brave enough to ask. Scholar, your final thought.
Every era tells ordinary people that its most powerful tools are not for them. Every era is wrong. The printing press was not just for scribes. The internet was not just for engineers. And AI, despite what the complexity of its language suggests, is not just for developers. It is for the legal professional who knows exactly what ordinary people cannot understand about the law, for the researcher who knows how broken the journal finding process is, for the traveller who knows how much uncertainty costs, for the musician who knows how invisible local talent is, for anyone who has ever looked at something and thought, this should work better than this. That thought is the beginning of everything.
Practitioner.
I have built legal platforms, safety intelligence tools, research assistants, marketplace applications, link managers, and systems that generate entire applications from plain English descriptions. And I will tell you, with complete honesty, that the most important moment in every single one of those projects was not the first line of code. It was the moment someone said, "This problem is real, it affects real people, and it deserves a real solution. That moment does not require Python. It does not require SQL. It does not require knowing the difference between a model and an engine. It requires paying attention and caring enough to act on what you see. You already do both. You always have.
Analyst.
The concepts we walk through today, model, engine, wrapper, inference, front-end, back-end, database, gateway, programming language, these are the bones of every application in the world. You now understand those bones. Not every technical detail inside them, but the shape, the logic, the reason each piece exists. And understanding the shape of a system is more powerful than most people realize. It means you can see it, evaluate it, question it, improve it. The curtain has been pulled back. What you do with what is behind it is entirely up to you.
You were never too ordinary for this world. You were never on the wrong side of the wall. You were never meant to stay outside the kitchen.
You just were not told what was in there.
Until today.
Until today.
Thank you for being here for this one. Then the best ideas are never kept to one person. Until next time, stay curious, stay informed, and remember, the most powerful thing you will ever build starts with a question only you are positioned to ask.